Welcome to another lecture from Data Formats. Today we are going to talk about formats for text documents. And before we get to today's formats, we have to start from the beginning, and that is with historical text formats. And when we think about storing text in a file, we already ran into this in the initial first lecture when we talked about two basic types of files. One is text-based and one is binary. So if you think back to that moment where we talked about text-based formats, we talked about encodings and so on. And when you imagine the most basic way of storing text in a file, that's what's called a text file, or also sometimes called a flat file. Text file is the data format, and it stores plain text. Plain text is a text without any formatting. It may have other meanings, depends on who is telling you about plain text and in which context, but the most usual context is that it is a text with no formatting. And when you have a text with no formatting, there is really not much to deal with. That's why the text file is a very straightforward and simple format. A text file is usually viewed as a sequence of lines of text, which means that what we have to really deal with are just two things. How do we know that one line ends and another line starts? So we are talking about line endings. And the second thing is the encoding itself. Initially, the encoding was the traditional US ASCII 7-bit encoding, but over the last decade or two, typically UTF-8 is being used when storing plain text files. So that's the encoding part. And when it comes to the line endings part, well, the situation there is not so clear. Nowadays, mainly two types of line endings are in use. The one coming from the Windows operating system, which is CR and LF, carriage return and line feed characters. So two characters denote the end of a line. On Unix-based systems and modern Mac OSs, it's just the line feed symbol. And if you come across a historical text file created on Mac OS before Mac OS X, then it is just the carriage return symbol. And for historical operating systems, there were also other options, but those you won't come across, I think, unless you work for a company with a historical operating system still running somewhere. Well, since a text file is so simple, it is the most application, operating system, and computer architecture independent format. And this is one of the reasons that actually a simple plain text file is quite common even nowadays, because it is simple. However, the downside of being simple is that people cannot format the text even a little bit. And formatting a text is something that people are used to, and therefore when we limit them to just a plain text file, they invent new ways of emphasizing, for instance, a text and formatting it even within a scope of a plain text file. So one thing that can happen, or that you can do when you want to emphasize a word in a plain text file, is that you capitalize this word. So this is the first example. What can happen and what is done sometimes in a plain text file. Another thing that you can do is you can surround the emphasized word with underscores, or maybe with asterisks, or, which is maybe the worst possibility is that you use a different spacing. So you insert, for instance, 1 or 2 spaces between each character of this word to make it stand out in the plain text. Well, all this you of course can do because there is no prescribed format in plain text. However, it is not the interoperable way to go, because one person will choose one style, another person will choose another style, and even if you then had a viewer that could emphasize the text in a better way, there is no way that such a viewer would support all the different syntaxes for this that people would invent within plain text. So this in 1992 led to a definition of rich text, which was designed with a few design goals in mind. One of those goals was that it needs to be extremely simple, yet extensible. And also by design, rich text has extremely limited capabilities. This is because at that time it was important that even implementations that do not support rich text would be able to at least extract the simple text from the rich text file. So basically, a rich text file defined a set of commands. Commands would be written between lesser than and greater than sign. There was a rule that a command cannot be longer than 40 characters. And there may be a negation command, which you can tell by its name, which starts with a slash. Then commands and their negations needed to be balanced. This has 3 exceptions. The lesser than command, which you would use when in your text you would like to have the lesser than character, but it was used to denote the start of a command, so you would have to have a command to actually output it. And then the new line and new page command. So these were the 3 exceptions that didn't have to be balanced because they didn't have a negation. And the last notable thing about rich text, beyond it being limited to US ASCII, but with explicit commands that switched to other encodings, is its compatibility with SGML. We actually didn't talk about SGML, but SGML is a language, can be viewed as a predecessor to both HTML or XML, or actually SGML provides the rules that both XML and HTML follow, and also this rich text format follows the same rules. So it is a meta language for rich text, XML and HTML. Remember that we talked about XML as being meta language itself, so SGML can be viewed as a meta language. Basically it says that you can have tags in your text which means something. And this brings us to the rich text example here. So we have a few simple tags, and a rich text like this can be rendered by an implementation, and such a rendering you can see in the example. So there is nothing special about it. It also treats new lines as regular white space. Only the NL command really says that there needs to be a new line, which is sometimes called a hard new line. So this is simple and limited rich text. It underwent some evolution. So 4 years later, in 1996, it evolved into enriched text. Note the difference also in the media type. So this is enriched text. And basically, in enriched text, you have more commands, and the special commands that were present in rich text were shortened. So for instance, instead of the LT command for outputting the lesser than character, you have now two lesser than characters, one after each other, and this means that a lesser than character should be outputted, which again you can see used in the example in the right hand side of the slide with the women and then with the smaller tag. And also in rich text there was a special command for new line. In enriched text, a new line is denoted by n+1 new lines. So a simple new line is white space as before, but if you have two consecutive new lines or more, then this actually means n-1 new lines in the output. Now, when we are going to mention HTML, we'll see that enriched text actually in 1996 was defined alongside or parallel to HTML. So HTML was already out there. Nevertheless, enriched text was defined in parallel to it. And there are two reasons. One is that at that time, not every internet mail parser or application supported HTML, not even in a way that would allow it to just strip the markup and display the pure text, which is possible with enriched text. And also HTML contains some features which are deemed not necessary for internet mail, and enriched text really focused on internet mail. So these were the reasons for devising enriched text in parallel to HTML at that time. Right, so those were formats used on the internet at that time, and parallel to those there is the rich text format, RTF, which was developed by Microsoft, and it has nothing to do with rich text or enriched text as defined in the RFCs. Rich text format is a proprietary format, which means that the specification is not available to anyone else than Microsoft, and it was meant as an alternative to the binary representation of text written in Microsoft Word at that time. So at that time, Microsoft Word documents were the .doc documents, and the format was binary, which meant basically, again, those formats were proprietary, which meant that no one else would be able to open or edit such a format unless they paid to Microsoft. And an alternative inspired by Czech, which is a language, a typesetting language we'll talk about today as well later. RTF, rich text format, was introduced as an alternative to the Microsoft Word doc format, and it was text-based. But again, it was proprietary, and again, the specification of the format was not available, which meant that whenever Microsoft decided to upgrade the specification, which was whenever they upgraded Microsoft Word, all the authors of the tools working with RTF needed to reverse engineer that format, which was a bit easier than with the binary doc format, but still, and update their implementations, which meant that Microsoft was always one step ahead when upgrading the specification. The rich text format, even though it is text-based, it is not meant to be edited directly. It is meant for saving and sharing of documents created in word processors. One interesting thing about RTF is that it identified its own set of encodings which were supported in RTF, and they were all the Windows something encodings present in the Windows operating system. Since RTF 1.5, which was introduced in 1997, there is support for Unicode. However, it is UTF-16, not UTF-8, and it is not in a way that the file itself would be encoded in Unicode. It is just that in the file encoded in the Windows encoding, you could use Unicode escapes. so not a complete Unicode support. Well, so this is the history of the rich text format. Now let's take a look at its practicality. So in the example on the slide, you see a handwritten RTF file. And below you can see that it really can be opened in, let's say, LibreOffice or Microsoft Word, doesn't matter. It can be opened and it is rendered as it is meant to be. Note that it uses the / commands, which is the inspiration by Czech. And for instance, the bold command has two variants, \b, which starts bold, and \b0, which turns off bold. And the same goes for italics. So yeah, this is RTF. But it's not that simple. As I mentioned, this is the handwritten RTF file and it can be opened. However, if you write the same thing directly in, let's say, Microsoft WordPad, which is the lightweight version of Microsoft Word, which is distributed with the Windows operating system, you write the same thing, format it in the same way and save it as RTF, you get something else. You get what you see. There is a definition of the font used. There is some metadata about the generator, which means the application that generated the file. And then there is the actual text. Okay, so it is not so clean as before, but this is still bearable, right? Well, let's make a detour and like this. We can write this typical Czech sentence with all the Czech diacritics present in the Czech language. And now the RTF file is not readable at all because the encoding actually doesn't support those characters and they all need to be transformed into escape sequences, which makes them totally unreadable. So that's another downside of RTF. But then again, the RTF file is not meant to be written and read as text. So it doesn't really matter, but it makes it harder for other applications to process. Now, if we write the same sentence with the same formatting in LibreOffice and save it, we can see that the RTF file is much bigger because now it contains different metadata, again, about the font used and the fonts available and so on. So the actual text is the little red thing on the bottom that you can see. And of course, if you do the same thing with Microsoft Word, so again, the same sentence, the same formatting, then the result is even worse because there are all the styles available in the Word instance encoded for some reason in the RTF file. So this is even worse. And because we are talking about historical text formats here, I cannot omit this typical Czech specific text format 602. It is a text format by Software 602, devised or created in 1988, so it is really historical, and it was used by the iconical Czech text editor Text 602, which was written for MS-DOS, and it was quite widespread in public administration and companies at that time. So everyone was writing in Text 602 at that time. Nowadays, of course, this is deprecated, but still a 602 file can be opened by LibreOffice, for instance. And if you take a look inside the 602 file, you can see it is also text-based. However, all the special commands, for instance, for formatting, they used ASCII control characters. So those are the ASCII characters with low numbers, which are not printable. Which means that when you take a look inside that file, you can see that you cannot see any control characters, but they are there and they are just not printable. So for instance, the ASCII character 02 switched on and off the bold formatting, and 04 switched on and off the italics formatting. So if you would open actually the file in a hexadecimal editor, you would see those characters there. But in the text output, it is not visible. Okay, so this was a little bit of a history lesson for text formats. Now let's move on to something more up to date, and let's talk about text formats for the web. And when talking about text formats for the web, I cannot start with anything else than HTML. However, I believe that nowadays everyone already knows HTML, so I will actually not go through HTML itself, but I will talk for a little bit about the standardization of HTML, which is quite interesting. So HTML was invented or written first by Tim Berners-Lee, the inventor of the web, in 1991 when he worked at CERN. So that was the first HTML specification. Then at that time, the web was not so widespread, so it was okay like that, and it was used by a couple of geeks at universities, and that was it. When actually the web became a thing, the IETF published HTML 2.0 as an RFC. So it was published by the IETF, and that's because the World Wide Web Consortium was actually founded in 1994. So that was parallel to the standardization process of HTML 2.0. But the consecutive versions, 3.2 and the version 4, were published by the World Wide Web Consortium as regular web standards, W3C recommendations. Now, note that there is a huge gap between HTML 4.01 from 1999 and HTML5 from 2014. That's a 15-year gap, which is quite a huge gap. And in between, actually, HTML5 was worked on. However, it was not standardized. It became standardized only in 2014, even though various web browsers and so on already contained and had implemented features from HTML5. That is because in the 2000s, the W3C actually focused more on XHTML, which is rephrasing of the HTML format in XML, so that the XHTML document is actually a valid XML document. And this became a concern for some of the huge players in the field, such as Apple, Mozilla Foundation, and Opera Software, because they viewed XHTML as unpractical and going against performance. And they actually didn't like that at that time W3C steered away from HTML and focused on XHTML. They wanted to stay with HTML and focus on performance and conciseness and so on. The difference between HTML and XHTML was, for instance, that in HTML you could have tags which are not ended in the usual XML way. So in XHTML, when you wrote a new line, you would also have to, which is the BR element, as in break, you would have to supply the ending BR element as well, or you would explicitly have to say that the BR element is empty, like you do normally in XML. Another difference is that in HTML you could have attributes with no values. You would just, for instance, when you have an HTML form using the input element and you want to say that this input is required, you would just add required as an attribute to the input tag, and that would be it in HTML. In XHTML, this is invalid because in XML attributes need to have values. So what would happen is that you would have an attribute required, and it would have a value also required. And this made XHTML a bit more wordy, a bit less effective. And there were more things like this, which basically made these huge players go their own way. And they started developing HTML5 features on their own without W3C. And this happened in 2004 when the WhatWG group, Web Hypertext Application Technology Working Group, was established by Apple, Mozilla, and Opera Software. And later on, also Microsoft and Google joined in. And this led to the HTML5 being developed within this separate group. Later on, the W3C actually released HTML5, 5.1 and 5.2 as recommendations, but then they decided that they will leave the standardization of HTML to WhatWG, and they actually decided this officially in 2019. So from 2019, HTML as a standard is being developed by WhatWG as so-called living standard, which basically means that it is changing all the time. This means that even the latest HTML recommendation by W3C, which is HTML 5.2, is now deprecated and superseded by this WhatWG standard. So this is another take on the history of HTML. But again, I suspect that all of you already know HTML, so I won't go into the details. Instead, I will introduce you to other syntaxes, other formats which are parallel or used in parallel with HTML. Before we continue, let me focus on HTML as the acronym. So it's a hypertext markup language. So language is clear. Hypertext means text with links to other documents, and this leaves us with markup. And markup is basically a text with visually distinguishable annotations. In the case of HTML, those are all the tags. And a property of markup is that when you take a look at the source code, you can clearly see what is the markup and what is the text. And when this document gets rendered, all the markup is no longer visible in the rendered document. So this is markup. And why I'm stressing this is that the next language or format we are going to talk about is called Markdown. And Markdown was developed in 2004 by John Gruber and Aaron Schwartz. And the goal of Markdown is to make the source code of the markup language. It is still a markup language, but the goal here is to make the source as readable for humans as possible. They actually placed readability above all else. And the goal is that the source code of Markdown actually can be published as is and can be read by people as is. It can be rendered, but that's secondary. Primary goal is to make the source code readable as it is. And as you can see in the example, I think they succeeded. Basically, Markdown is a specification of this markup language and a way of converting this into XHTML, which then gets rendered by web browsers as usual. This actually is the distinction between Markdown and HTML. Markdown is called a writing format. So it is a format for actually writing by hand of the text, manual writing. Whereas HTML is viewed as a publishing format. So a format in which you publish the documents so that they can be read or rendered by web browsers, but you don't want to write HTML by hand. Those of you who tried know that HTML is wordy and it is not that convenient to write by hand. Whereas when you just need to write down a document that eventually gets published somewhere on the web and you want to write it down by hand, and you don't want to use some content management system that you write in using a WYSIWYG editor, and you don't want to use, let's say, Microsoft Word and then print out a PDF file and publish it on the web. You just want to write text, which is concise, then Markdown is the right way to go for you. And let me mention, there is a nice online editor of Markdown, where on the left-hand side you write Markdown, on the right-hand side you see the rendered HTML, so you see the web page. And this actually is what the authors had in mind when they designed Markdown. this kind of editor, which is split screen, where you write Markdown on one side and you see the rendered result on the other side. And the transformation goes through HTML. That's why now when we'll go through Markdown, I will always show you a piece of Markdown, then what it corresponds to in HTML, and how it looks like in a web browser. And the first thing we'll talk about are headings. In Markdown, there are actually two types of headings. This is the first heading, called a settext style. Settext was a predecessor to Markdown. So from that format, these heading notations came to Markdown. So the notation is that you just write the header and then you underline that header with equal signs. So that's the first level header. A second level header is also underlined, but only by dashes. So this corresponds to how you would normally write your header when you write it by hand into your notebook. You would write the header and then you would underline it twice when it's the most important one, or once when it's the second most important one. And this corresponds to the H1 and H2 headings in HTML and gets rendered as such. Now the second style is the ATX style, which ATX is again one of the predecessors of Markdown. So ATX style, it supports all 6 levels of headings, as in HTML you also have 6 levels of headings, and it has a different syntax. So it has the number sign or a hash sign, then a space, and then the text of the header, and that's it. And the second level has 2 number signs, the third has 3 number signs, and so on for all the 6 levels. So the HTML is unchanged here, and so is the rendering. It's just 2 styles of headers in Markdown. Now, if you want to emphasize some text in Markdown, you can do it in the same way that I showed you in the beginning of this lecture. So as you would do it in plain text, you would do it in Markdown. So not the capitalization, but the surrounding by asterisks or underscores works in Markdown. And if you want to emphasize something strongly, you use 2 asterisks or 2 underscores, and that's it. Now, this corresponds to the EM and to the strong elements in HTML. And more than before, you can see how Markdown is closer to what is actually rendered in the end, which is the third column here. So Markdown looks as similar to the rendered result as possible, whereas with HTML it starts to be a bit different. Now there is of course a support for lists, and we'll start with unordered lists. So here we have 3 styles for unordered lists in Markdown. We have asterisk based, plus based, and minus based, and all those are the asterisk character, then white space, at least one space, but even more is possible, and then the item. So a simple list as you would do it in plain text, and it gets rendered as such. In HTML, this is a bit more complex because you need to have the unordered list element, the UL element, and then you need to start and end each line item or list item. So again, Markdown is a bit simpler here. With the ordered list, it is similar. So as you would write an ordered list in plain text, 1, 2, 3, with a dot and a space after it, and that's it. The interesting thing with ordered or numbered lists is when you want to edit them and add an item to the middle. So for instance, we have red, green, and blue, and if I want to insert, let's say, violet as the third item, and blue will become the 4th item. In HTML, how it worked was that you just added a list item and the rendered list was renumbered, right? If you use this notation in Markdown, the renumbering is up to you because it looks like a numbered list already. If you want to avoid this, you can use number 1 for each of the ordered list items, and then you can avoid renumbering the list if you add an item into the middle. So this is also possible. However, then it is less readable in its source form. So those are two representations of ordered lists in Markdown. Now what's important, of course, are links, because we are still talking about hypertext. So a syntax for a link in Markdown is square brackets surrounding the word or the text from which the links go somewhere. And then in regular parentheses is the URL with the link. Optionally, you can add a title, which then is displayed as a tooltip when you hover your mouse over that link in your web browser. So this is just different from HTML, but it doesn't save anything. It's just different. But what is important is that this is just one style of links in Markdown. There is another style, which is called a reference style, and this one is very different from HTML, and actually it is more similar to how you would link from a printed publication, let's say. This one actually makes the Markdown source much more readable. It works like this. You again surround the text with square brackets, but then with another pair of square brackets, you identify that link and you go on with your text. And then at the end of the whole Markdown document, you define the links, which are here in the example, they are identified by 1, 2, and 3, but the identifiers can be arbitrary. And you define those links with, again, square brackets, identifier, colon, space, and the URL, and space, and the title used in the link. Now, the same thing in HTML doesn't have support like this, so there those links need to be in line. And here you can see how the text which gets rendered is really very similar in Markdown, but really very different and hard to read and hard to write in HTML. So this reference links style is where Markdown clearly wins with readability. There is an option to the reference style links that you don't have to specify a separate ID or a new ID for that link, and you can use the actual text of the link as the ID. And then the second pair of brackets is empty, and you continue with the text. And then when you define the link, you define it with the text from which the link goes somewhere. So again, this is very nice. And in some flavors of Markdown, the second pair of square brackets can actually be omitted. So then you have just text surrounded by brackets and nothing more. So it really looks almost identical to the rendered representation. And also it has more advantages, which is that you have all the URLs in one place at the bottom of the document. So when you need to take a look, for instance, at where your text links to, or you want to change some URLs and so on, it is much easier to have them all in one place than to go through the entire text searching for the inline links. So this is a nice option that Markdown uses. Now, images are very similar to links. You can spot the images in Markdown or use images in Markdown with the exclamation mark before the square brackets. Now, the square brackets will contain the alternate text to the image, which gets shown whenever the image fails to load, for instance, or is missing. Then the URL of the resource with the image, the file, and the title of the image, again displayed when you hover over the image. So here I don't have an image to show you, so I just show you how the images in Markdown correspond to the image element in HTML, which I suspect you already all very well know. And also with images, you can use the reference style, which again makes the source code of Markdown very readable. Now, especially for us, computer scientists, it is important to include code in our texts. And again, this is a discipline where HTML is very hard to use or write by hand. And in Markdown, this is done very easily. And this is inline code can be inserted by backticks. And whatever is inside backticks gets actually translated to HTML properly. So for instance, the lesser than and greater than sign characters, which cannot be used as they are in HTML, need to be escaped as named entities. So this is done for you within the Markdown to HTML transformation. So really, when you take a look at the rendered text, it looks the same as the Markdown text, except for the backticks that surround the code parts. So this is, again, a very nice feature of Markdown. Now, this was inline code, and if you want to use code blocks, you can do that also easily. You just indent the code block with 4 spaces or 1 tab, and whatever is indented gets translated into a pre-formatted code block in HTML. So again, very simple. Now, another thing, horizontal rules. If you want to separate your document into sections by horizontal rules, you can do that in Markdown with 3 or more asterisks or 3 or more dashes, or asterisks with spaces among them. So all these options get translated to the horizontal rule element in HTML and get rendered as a horizontal line. Now, this was the basic Markdown document specification as written in 2004. However, the way it is written, and you can take a look, it's quite an easy reading. It is ambiguous, which means that when you are actually trying to write an implementation according to this specification, you have some choices that you need to make as a developer. And this is always bad when you write a specification and the implementers have some choices to make. This means that when multiple developers will try to develop a software according to the specification, each of them will make different choices, which will result in incompatible implementations. And this is what happened with Markdown. The implementations actually diverged and many different incompatible flavors emerged. This is, of course, not what you want when you create a new language, because now your audience is split into those using the individual flavors and they are not interoperable among each other. So this is a bad thing. And what Markdown fans actually did in 2014, they created Common Mark, which is a proper unambiguous specification of Markdown and also a comprehensive set of tests so that when you write an implementation against Common Mark, you can test your software with the tests that go with the specification and see whether your software is or is not compatible. Now, Common Mark was developed from 2014, so 10 years after Markdown, and the last version or latest version is from 2019. The version number is 0.29, so it might not be final yet. However, it already has or is backed by some strong implementers such as Discourse, GitHub, GitLab, Reddit, Qt, Stack Overflow, Swift. So this actually is a good thing because it means that the specification is implementable, and since those big players support it, this is the way to go about Markdown. So Common Mark. Now, some features that we were used to in, let's say, HTML were missing from Markdown. For instance, tables. There was no mention about tables in Markdown. In Common Mark, tables are supported, and we'll get to those. Another feature that is added in Common Mark is called fenced code blocks. And this is actually used quite a lot on GitHub, for instance, when you are writing issues or documentation and you want to use a block of code. This fenced code block is the way to do it. It starts with 3 backticks and a new line and ends with a new line and 3 backticks. And whatever is in between those is rendered as code. Nice feature that Common Mark supports, and it is supported, for instance, on GitHub, GitLab, and so on, is that you can add an info string after the backticks, identifying, for instance, the language used. And this gets picked up by a syntax highlighter, and then the code gets syntax highlighted. So this is a nice feature. There is an alternative to this, and this is with 3 tilde characters. So I actually personally haven't seen this used, but I believe it is used. I personally use the backticks notation because it is similar to the inline code being used also. Now another feature are hard line breaks. So if you absolutely must have a line break in your text somewhere, which normally goes against good practice because you should leave line breaking to the browser so that you don't interfere with what the browser decides is the best line break position. But if you need to have a line break there, you can do it in Markdown simply by putting 2 spaces before the new line, or a backslash before the new line. So this is how you do a hard line break in Markdown, and it gets translated into the BR element in HTML. Now, in Markdown, sometimes you need to insert HTML blocks. So you can do that just like you see in the example. You just start writing HTML, and the Markdown specification actually contains a set of used tags in HTML, and when it detects such a tag, it switches into an HTML mode, and the HTML gets output as is. When this tag is ended by the end tag, the processor gets switched again into Markdown mode, and the rest of the document gets translated as regular Markdown. So the OK text at the end of the example gets translated as a regular paragraph OK in HTML. Now the tables are actually not part of Common Mark even. They are added in some flavors based on Common Mark, such as Cramdown. Cramdown has syntax for tables that you can see. So it uses pipes as separators of cells on one row, and new lines as separators of rows. And if you want to use table header, which is a special part of the first few lines, one or few lines of the table, if you want to use that feature, then you insert a cell filled with dashes, or in this case starts with a colon and a set of dashes. This again depends on the specific Markdown flavor used. This is because this is not part of Common Mark, which means it again has to be added as an extension, and therefore each Markdown flavor adds it differently. So this is tables in Cramdown. Now the Markdown use case examples here, I have GitHub or GitLab, where when you navigate to a repository, you typically have it initialized with a readme MD file, which is a Markdown file, and this file gets also displayed whenever you are in a repository without actually selecting it and displaying it separately. So in GitHub, GitLab, Markdown is used as a native markup language. Another use case is Jekyll, static site generator. This means that you write your websites in Markdown, then you call Jekyll, it translates all the Markdown or HTML into rendered HTML static files, and those static files get published on a web server and served as static files. It has its advantages. It is safe. It can be hacked because there is no editing feature on the web itself unless you edit separately. It's just static files, and it supports all or some of the features that you would normally need a preprocessor like a PHP script for. like including parts of web pages and yeah, mainly including like headers and footers and so on. So Jekyll static site generator, it is used on GitHub pages. So GitHub has support for adding a website presentation to a repository, and it's called GitHub pages, and it uses Jekyll as the static site generator there. So when or if you use GitHub pages for your software, you will use it with Jekyll, and then you have an option to write your pages not in HTML but in Markdown. Actually, what you see is a combination of Markdown and another file format that we talked about, which is YAML, and it is used as a metadata format in Jekyll pages. Okay, so this was Markdown and its use cases. Now, HTML and Markdown are the most widespread formats for text on the web, but there is a third family of formats that is also quite widespread, and that is Wikitext. Wikitext is the format used in wikis, such as Wikipedia, but all the others as well. There is no formal specification, so whatever your implementation of wiki supports, that it is. There is some commonalities that I'll show you, but other than that, it's basically every implementation its own Wikitext flavor. It all started in 2002 with MediaWiki being implemented, which is the software now powering Wikipedia. It had, of course, some predecessors, but the Wikitext as we know it was used there. And now MediaWiki is the software powering Wikipedia and tens of thousands of other wiki sites. But it is not the only implementation. There are tens of other wiki implementations, commercial and free and so on. And they all differ in the exact Wikitext syntax they support. Now, if you take a look at the example and the rendered HTML, you can see that it is wordier and it is less readable than Markdown, definitely. So that's one thing. But on the other hand, if you want to run a wiki, then you typically need much more features than what you have in Markdown. You need to have support for references and links to other wikis and structured info boxes and so on. So it makes the text less readable. You can see for yourself, if you go to Wikipedia and try to edit any page you find there, you will see that the Wikitext is quite a complex syntax. Also, if you take a look at the full guide, which is linked from this slide, you will see that the guide is quite long. So I'll just show you the basics. So headings have another syntax, yet another syntax, equal signs, then a space, then the heading text, and then equal number of equal signs at the end. And the more equal signs you have, the deeper heading you are defining. The disadvantage here is that you need to keep track of the number of equal signs on each side of the heading. So this is a bit impractical. Now, italics, bold, and both differ in the number of single quotes surrounding the text you want to format. So 2 single quotes are italics, 3 single quotes are bold, and 5 single quotes surrounding your text is a combination of bold and italics. Lists are quite similar to Markdown, so the asterisks are the unordered list and the number signs here are the ordered lists. So those are lists, but the most important difference or feature of Wikitext are links. Remember that when we talked about linked data, I illustrated the linked data principles on a wiki page, and I tried to imagine or describe what it would be like if all the links disappeared, which is the state of data nowadays, right? Where the data is not linked, which is as if in Wikitext there were no links. So those are the links, and in Wikitext there are 2 basic kinds of links. One type is intra-wiki, which leads to another page or another section of that page in the same wiki. Those are surrounded by double square brackets, and inside those brackets you have the name of the page you want to link to. In wikis, the page names are unique, so the page names can be used as link targets instead of some arbitrary IDs. So that's what is done with Wikitext, so you always know to which page you are linking. And also, if the text of the page is not exactly what you want the text of the link to be, you can continue with the link text directly after the closing double square brackets, as you see in the second example. Now, if the text is completely different, then you can insert a pipe and rename the link to whatever you want. So those are intra-wiki links. Besides those, there are also links to other URLs, the usual hyperlinks that we know from HTML. And there you can just use them as they are, and they get interpreted as a link, which is both the target and the text. Or you can surround those by square brackets. If you don't specify a name for the link, they will be numbered. And if you specify the name after a space in the square brackets, you'll get the usual link coming from the word that you used for the name. Now, here, why the space is enough to separate the URL and the name? Well, space is an invalid character in URI, IRI, URL, and so on. So it is safe to be used as a separator here between the URL and the rest of the link definition. Okay, so this was Wikitext, the third common type of text on the web. So if you come across a text on the web, the chances are quite high that the text will be written either in HTML or in Markdown or in Wikitext and their alternatives. Up to now, we were talking about text on the web. So it meant that eventually the text would end up as HTML and displayed by a web browser on a computer. Now, there is another approach to processing text on a computer, and it is called TeX. I already mentioned TeX as an inspiration for the RTF, rich text format, developed by Microsoft. So now let's take a look at what TeX is. It is a typesetting programming language and software, which means it is meant for typesetting, well, books and papers and articles that will end up printed eventually. And it is actually older than any of the formats that we talked about up to now. It is from 1978, which is ancient, developed by Donald Knuth, and it is free, which is nice. And the goal here is to allow anybody to produce high quality books with minimal effort. And also to provide a system which would produce the same results on any computer at any point in time. At that time, in 1978, computers differed much more than they differ today. So this was a very important design goal to be achieved by TeX. Nowadays, TeX is a de facto standard for publication of texts in technical fields such as computer science, math, engineering, and physics. And these, of course, include bachelor's, master's, and PhD theses at universities. So TeX is what you will probably be using for your thesis. Now, if I show you an example of TeX, which is the source is the first two columns and the rendered result is the third column, you might get a little bit worried when you already know that you will probably use TeX for your thesis because it looks quite complex. But there is actually no reason to worry. This is because you probably won't be required, or you won't have to write TeX in its raw form like this. those who write Czech in this form are those who define the visual styles and templates of the actual documents. So those actually get to work with Czech, where, as you can see in the example, you deal with how big a space between two lines is and the alignment and all this. So basically, that's all part of the style or the template of the document. So if you are a template author, then you will write Czech. However, if you are just an author of a text wanting to use Czech to produce a nice publication or a nice typeset document, then you'll be working with LaTeX. LaTeX is a set of Czech macros, so a set of smaller Czech programs which make writing of documents in Czech easy. It was developed a bit later in 1984, but still quite a long time ago by Leslie Lampert, and the goal here was to focus on authors of texts so that they would need to focus on formatting and styling of their documents, so that they would focus just on the contents of the documents and that they would leave the styling and formatting to the authors and designers of Czech templates. Now, this is because letting authors deal with formatting of documents ends up in two things. One, lots of author time gets consumed by design because typical text authors are not designers. And second, it results in lots of badly designed documents by the authors. So this is not desirable, and this is what LaTeX deal with. The result of, or when LaTeX file gets rendered, the result is nowadays a PDF file. So a file which you can publish on the web, and then you can display it on a computer, or typically you can print it and it looks the same. Now, if you look at a LaTeX example, it looks much nicer, right? It just shows you that there is some header, and then the document begins, and then there is hello world text, which you can see rendered at the bottom of the example, and then you can write, for instance, nice math equations, which would be quite hard to get just right, for instance, in Markdown or HTML. There is, of course, the mathml extension to HTML, but let's not talk about that now. So this is LaTeX. It allows you to write documents in Czech and focus just on the content of the document. What LaTeX does for you is, of course, the typesetting itself, but it doesn't have to be just books. It can be articles, it can be also slide presentations, and so on. So it allows you to typeset, to stick to a certain format, and you can focus on the content and not the formatting, which is a huge benefit, believe me. Then it handles or supports even very large documents. So try working on 200 or 300 pages of text in, let's say, Google Doc or in Microsoft Word. Those are terrible experiences that you can have. In Czech, this is easy because you just write your text and then you compile it into the resulting document, and you don't have to worry about formatting that much. It doesn't apply universally, but it really helps with lots of the formatting. It supports complex math formulas, which you have seen in the example at the beginning. It automatically generates bibliographies and tables of contents and so on, which is also a very nice feature, which you will appreciate again when writing a thesis, for instance. And it allows you to typeset in multiple languages in one document. So yeah, also a nice feature. Now, as to editors, you can find a LaTeX distribution online that you can download and run on your computer, or, which is at least by me, the preferred way of using LaTeX is Overleaf, which is an online LaTeX editor. It also contains a very nice tutorial, and basically it allows you to write LaTeX, and it renders it as PDF or as a preview for you as you write it. So it is all online. You don't have to install anything. You just create an account and start writing in Czech. Right, because Czech and LaTeX is so important, we will go into more details here. So when we want to start writing LaTeX, we'll start with a very first document, which is very simple. And for that, we need some commands. Now, commands in Czech start with backslash and the command name, and then in either curly braces or in brackets, you supply parameters to that command. So here we'll use the document class command to actually say that the document we will be writing uses a certain document class, which is the template or the style that the document will use. So that's the document class command. And then there is a whole set of commands that look like the begin document and the end document command. So actually, document here is what's called an environment. It sets the text parser to output the text inside that environment in a certain way. And the whole document is also an environment. And to start and end an environment, use the begin and end commands with the name of the environment. So this you will use, for instance, for definitions or listings of source code and so on. But there is an environment that actually represents the document itself, and that's the document environment. Now, what is before the begin document command is called a preamble. So after document class, but before begin document is a preamble. And in preamble, you specify which packages you will use. Now, packages are sets of named Czech macros, and you can then use them as additional commands. So basically, you can view a package as a set of commands and their implementations in Czech. All the Czech packages are stored in C10, Comprehensive Czech Archive Network. Currently, there is more than 6,000 packages, so whatever you need, you will probably find there and multiple times in various packages. And when you want to use a package, you need to define that using the use package command in the preamble. In this example, it is the same example as from the beginning of the talk about Czech. We'll want to display some math equations, or a math equation displaying a binomial and a fraction. Without any package, Czech itself or LaTeX doesn't know the binom and frac commands. So we need to add a package that implements those commands, and that package is AMS math. So we'll say that we will use this package, and then we can use the binom and frac commands. Now there is one more thing to note, and that is the math mode. The Czech processor runs either in text mode or math mode. And normally you run in text mode, and when you want to switch to math mode, because some commands like these binom and frac only work in math mode, you can do it either inline, which we'll see later, or you can write a whole mathematical block. So you switch on the math mode by backslash and square bracket, and then you switch it off, and you are back in text mode. So if you see in your LaTeX file this backslash bracket, it means beginning of the math mode. So what else goes into the preamble? That's metadata, such as title of the document, author of the document, and date when the document was published, for instance. So that goes also into the metadata, into the preamble. And one notable thing here is the specification of the input encoding as UTF-8. Now, modern versions of LaTeX should treat UTF-8 as the default encoding of the input. However, some implementations, such as Overleaf, do not have this as default, and you need to specify it. But it's quite simple to specify it. You just use the input enc package, and you pass in the UTF-8 parameter, and that's it. You can then write your TeX in Unicode, which is especially useful for Czech texts. Now, if you want, if you want to write out the metadata, then your document class actually says how to do that, and all you need to do is place the make title command in the appropriate place in your document, for instance at the beginning. So here in the beginning of the document we have the make title command, and what it does is what you see on the right. Basically the article class specifies which metadata gets printed out and how it is formatted. Again, you don't have to worry about this. Everything is specified for you in the document class. Now you may want to structure your text into parts, and LaTeX as such has 7 different levels of sectioning the text. The highest level is part, then is chapter, then section, subsection, subsection, and paragraph and subparagraph. Not all document classes need to implement all these levels. For instance, the article class doesn't implement the part and chapter sectioning. So in a typical article, you start with a section. And the result, again, is on the right. LaTeX takes care of numbering and formatting and all that. Now, it may happen that you want to have a section and you do not want it numbered. Then for that, there are the asterisk versions of certain commands that would normally produce a numbered thing, and these versions produce actually not numbered things. If you section your text like this, then you can already automatically create, for instance, a table of contents. Now, as to paragraphs and new lines in TeX are treated as regular white space. So a new line in TeX actually doesn't mean there will be a new line in the resulting text. If you want a new line, you probably want to start a new paragraph. And you start a new paragraph by having 2 new lines in the source file. Now, there are 2 options of writing a paragraph. Either you write the whole paragraph as 1 line of text, which is what people sometimes do, but I do not recommend that. I very much recommend, and it is a good practice, to put one sentence or each sentence on a separate line. And there are reasons for that. When you then version or comment on your text source, for instance on GitHub or in Overleaf, there is also a commenting functionality. It is much better or much easier to focus on the place that you want to discuss if you place each sentence on a separate line. For instance, in GitHub, all the versioning and commenting and so on is focused on lines. So if you have 1 sentence per line, you can focus your comments and changes quite nicely. If your line is very long and contains the whole paragraph, then it is hard to work with and collaborate on. So a good practice when you are writing your thesis, for instance, is put each sentence on a separate line. Now, lists in LaTeX are implemented as environments. So you have the itemize environment for unordered lists and enumerate environment for ordered lists. In both environments, you use the item command to start a new item. And that's it, quite simple. Now, it may happen that you want to reference or link from a part of a text to another part of a text. In Czech, for that, you first need to define a label, which basically says, I want to create links that or references that lead here. And then when you create those references, you do that by the autoref command or a ref command, but autoref command is smarter. It is implemented in the hyperref package, and it references the label, but it references it in a correct way. It deals with the proper name of that label, such as section for sections, figure for figures, and so on. So you don't have to actually think about it in your text, whether you are referring to a figure or a section or something else. It also deals with the proper case of the letters of the label. So if your link to a section is in the middle of a sentence, like mine is, the red one, the section will start with a lowercase letter. If the link would be the first part of a sentence, it would start with an uppercase letter. So this is all dealt with in the autoref command. And also, when you then produce the final PDF, this reference using autoref will be clickable in the PDF. So labels, references, and the autoref command. Now, if you want to use figures, there is a construct that you can reuse, and that's the figure environment, which you start with centering if you want the figure to be centered. Then include graphics command actually points to the file containing the image, and here it is parameterized so that it says that the image should be quarter of the text width. You have many other options of sizing that image, but this is the most common way of using multiples of the actual text width. Then there is caption, which is the name of the figure. Again, you don't have to worry about numbering. The caption gets prefixed by the proper name, which is figure, and the proper number according to the position of the figure in the text. You want to define a label because you want to be able to reference this figure from your text, as is done in the example. So again, I just in the source, I just autoref the label, and it inserts the word figure and the number, and it is all a clickable link. Now, it is a good practice that every figure in your text should be referenced from the text. So again, think about that when you are writing your thesis. Another thing that is quite common in LaTeX are tables. So for tables, there is the table and tabular environments, and the tabular environment you can set up with the column format and separators. So two pipes mean that there will be a double line. A space means that there will be no line, for instance, between column 1 and 2. And the C letter means that the text in the column will be centered. Then you start with the table, and for that you use the regular horizontal line command. You write the contents of the columns and separate the columns by ampersand symbols. When you are done with one line of the table, you use the new line symbol, which is the double backslash, and you continue with the next line. Then, of course, you specify again the caption of the table and the label you want to use to reference that label from the text. Now, the cool thing about LaTeX I mentioned is that it takes care of bibliography for you. And it does that by using BibTeX, which is another piece of software which usually is included in your LaTeX distribution. Now, bibliography, again, has many different styles, and BibTeX, what BibTeX does is that it keeps your library of references in its own BibTeX format, which is what you can see in the references.bib file example. So that's a special BibTeX format, and it is independent of how the reference will look like in the text when it is rendered. because that is again the matter for the bibliography style, which is again defined separately from the whole document style. So there is bibliography style, which you set, and then you include your bibliography with the bibliography command. And BibTeX actually generates all the used references in the proper format or style specified. So this is very useful. It takes care of the numbering and all that. And all you need to do in your text is use the cite command with the ID of the BibTeX entry that you want to cite. For instance, a paper or a web page and so on. So it allows you to keep a library of references, reference that from the text, and not worry about the style, and not worry about having references that you haven't used in the text, because only those references which are used in the text get rendered. Now you may ask, where do you get the BibTeX records for publications? So there is, for instance, DBLP, which is a repository of publications, and it contains automatic export of BibTeX record, but also other repositories of publications also typically have a functionality that allows you to export this BibTeX record. So you just export it, place it into your references file in your LaTeX project, and you use that, and you don't have to worry about formatting of those bibliography entries, which is very useful and very nice. Now, the final thing I wanted to say about LaTeX is the support for advanced or complex math equations. There is lots and lots of commands regarding the equations, so I won't go into detail here. I will just mention that we already talked about the math environment, which you need for those equations, and you can also switch into inline math mode by the $, and that allows you to write variable names and so on. And note that there is quite nice support for superscript and underscript, which are the lower and upper indices used often with variable names, and that's the underscore and the caret sign. So those you can use to do super and underscript. So that was LaTeX that you will probably use for your thesis. Now, it was focused on producing a nice printable publication. However, it is not used, for instance, to publish web pages. For that, we have the web formats. But there is a way all this can come together, and there is an alternative to actually producing your file in LaTeX and then not being able to publish it on the web in other form than a PDF. There is a software called dokie.li, which is based on linked data, and it is a client-side editor for decentralized article publishing, annotations, and social interactions. This basically means that you write your document as HTML. You store that HTML in your solid pod. Remember, in our first RDF tutorial, there was a task for you to create a solid pod and play with it. So solid pod is your personal storage implemented by linked data technologies. So the HTML file is stored in that solid pod, and when you view that file, dokie.li itself gets linked to that file just as a JavaScript link and a CSS file, and that's it. So it's simple to add to any web page, and it allows you to actually edit that web page as you see it in the browser. And then you can save it in your own solid pod or into other solid pods when you want to collaborate, for instance. Then all this text is in HTML, and there are predefined CSS style sheets that make the text look like produced by a Tech implementation. And it supports annotation of text by RDFA, which is actually an RDF serialization into attributes of HTML. And It allows you to comment, like, and collaborate on parts of the text directly in your web browser, and the conversations, likes, and so on are also stored as RDF data in the user's solid pods. Actually, if you are going to, for instance, write a paper as part of your thesis to be submitted to a conference or to a journal, nowadays web-focused journals and conferences actually encourage publications to be submitted as HTML, but then for them to be printed in a book, in proceedings of a conference, they need to be properly formatted. So that's where the CSS kicks in. But if you take a look at dokie.li and try to play with it a little bit, you will see that you have one text in HTML. The HTML is actually quite readable. And you are just switching CSS style sheets, and the text looks like a text output, a 2-column text output, or an HTML page, and it is still the same text. And it is stored in your solid pod and as HTML. So this is a nice compromise between tech and writing HTML web pages when it comes to publishing documents. Okay, so now we know what we can use the text formats for and how we can represent text either on the web or prepare it for printing. What is left to be said is what we can do with text when we have it represented. So one thing we can definitely do is we can search in a single document. We can search using the exact match, which is the simplest method possible, where we search for the exact phrase or exact keyword, and we get where the keyword is in the text. We can use wildcards to get more vague queries, and if we need more expressive power, we can use regular expressions to find or change parts of the document. So those are the basics. When we have lots of text documents, we can put them in a database, and on top of the database, we can create an index and then search the database for documents matching the query. An example of such an index is an inverted index, where basically each document gets scanned on insertion to the database, and then there is a table of words and links to the documents containing those words. There are two levels of the index. It can be record level, which is what I just talked about, and what is also seen in the example. Or for some methods, for some search methods, it's better to have a word level index, where in addition to the document ID, you also have the word position in the document. And this you can use, for instance, for proximity search, which allows you to search for words within proximity of other words. Example in the right-hand side of the slide is the third one, proximity search, where we search for the word data, and within the neighborhood of data, within 3 words, we want to also see the word open. So if you want to use an index for this method, then we need a word level index for that. Otherwise, again, using that index, we can search for documents based on keywords, or maybe a bit complex queries with Boolean connectives such as and not. We can also employ some sort of edit distance, which allows us to search for words that need to be changed a little bit to match what is in the document. That's called fuzzy search. We can also compare text files. For instance, in GitHub, you get a line-based comparison where you can see the difference between 2 states of the same file. Another thing that can be done is named entity recognition, where you have a text on the input and you search or you try to identify entities referenced in that text. One of the implementations of this is called DBpedia Spotlight, which tries to find occurrences of entities in text and link them to DBpedia, which is the linked data version of Wikipedia. And this goes in four phases. First, based on the text and the labels of the entities in DBpedia, DBpedia Spotlight tries to just spot the possible entities in DBpedia that could be referenced just based on the names. Now, for each name, there is a list of candidates, and this list of candidates gets filtered using various techniques. Then, based on the context, there is the disambiguation phase that basically allows you to distinguish the entities which have the same names but mean different things. Then there is a filtering phase, and the result of the filtering phase is the final annotated text, where in the text you can see the identified entities and their links to, or their URIs in DBpedia. So there is a demo, you can try it yourself for various languages. And finally, when we have a text in HTML, we can semantically annotate it, which basically turns the document also into an RDF data file. The syntax for this is called RDFA, and you can see an example of that in the slide, where we have two entities and some RDF triples embedded directly in the HTML document, which means that people in their browsers see a regular rendered HTML document, but if you use a RDF distiller or RDFA distiller, which turns that file into a regular RDF data model, you see RDF data. So this is a way of embedding RDF annotations directly in an HTML file. So this was a brief overview of examples of things that can be done with text documents.